Welcome to AI.Code.Cast. Today, we're going on a deep dive into a classic coding problem, the kind that shows up all the time in technical interviews.
Yeah, converting Roman numerals to integers.
Roman numerals? Really? Yeah, you might be thinking.
Right. It sounds a little, I don't know, basic, maybe. But trust me, this deceptively simple challenge, it's a favorite for a reason.
I'm sure you're right. What makes it so tricky?
Well, it's a really great way to test how you think algorithmically and how you handle these quirky little edge cases.
Later cases.
Yeah, the ones that can trip you up. And it also makes you think about efficiency and optimization, which, as any coder knows, are like the bread and butter of good code.
For sure.
Yeah.
So what do we have on the menu for today's deep dive?
Well, we've got 3 different approaches we're going to unpack.
3? Yeah.
Each one has its own little twist. We'll break down the logic behind each one and then explore its strengths and weaknesses, and then we'll see how they compare, in terms of efficiency and readability.
Okay, before we get into all that, let's just kind of like level set. Make sure we're all on the same page.
Yeah.
Okay. What exactly is the problem we're tackling here?
Okay, so imagine you're given a string, right? And it represents a Roman numeral.
Okay.
Something like MCMXCIV.
Oh, yeah. That's good to win.
Your task is to write code that converts the string into its corresponding integer value, which in this case would be 1994.
So it's like translating from one number system to another.
You got it.
But with this added challenge of those subtractive cases that Roman numerals have.
Exactly, like how IV represents 4, not 6.
Right, because the I comes before the V.
Exactly. That's where it gets interesting, because if it were just a simple additive system, it would be totally straightforward. But these subtractive cases force us to think carefully about how we're processing the Roman numeral string.
So where do we even start with something like this?
Well, a common starting point, and I think especially in an interview setting, is to just think about like a brute force approach. It might not be the most elegant or the most efficient solution,
Right.
but it does get the job done.
It's a good place to start.
Yeah, and it helps you wrap your head around the core mechanics of the problem.
Okay, so brute force. How would we actually do that?
The first thing we need is a way to map each Roman numeral symbol to its integer value.
Okay.
So we could use something like a dictionary or a hash map, where the keys are the Roman numeral symbols and the values are their integer equivalents.
So like I maps to 1, V maps to 5, X to 10, and so on.
Exactly. Once we have that mapping set up, we can start iterating through the Roman numeral string.
Like reading it.
Yeah, from left to right.
Okay.
And comparing the values of the symbols that are like right next to each other.
And that's where we have to deal with those subtractive cases, right?
You got it. So if we come across a symbol and its value is less than the symbol to its right, then we know we've got a subtractive case.
Okay.
So in that case, we subtract the current symbol's value from the next symbol's value and add that result to a running total.
Got it. And if the current symbol's value is greater than or equal to the next one?
Then it's just a simple addition. We just add the current value to the total and keep moving.
Okay, so back to our example, MCMXCIV. How would this brute force approach work step by step?
All right, so we'd start by looking up the value of M, which is 1,000.
Right.
Then we'd compare it to the next symbol, C, which is 100, since 100 is less than 1,000.
Subtractive case.
Exactly. So we subtract 100 from 1,000, which gives us 900, and we add that to our total. Then we move on to the next pair, C and M.
And C is still less than M.
Yeah, so in another subtractive case, we subtract 100 from 1,000, get 900 again, and add that to our running total.
Which is now 1,800.
Right, and we just keep going like that.
Comparing.
Yep. Handling XC is 90 and IV is 4, and eventually we land at our correct integer value of 1994.
This brute force method, it seems pretty straightforward.
Yeah.
But I have a feeling it might not be the most efficient way to do this.
You're absolutely right. It gets the job done, but it can be a little clunky and inefficient, especially if we had a really, really long Roman numeral.
Yeah, that'd be a lot of back and forth.
Yeah. Luckily, there are more elegant ways to do this.
Oh, good.
And we'll get into those in the next part of our deep dive.
Can't wait. See you there. Welcome back to AI.Code.Cast. In the last part, we talked about this brute force approach to converting Roman numerals to integers.
Yeah, it worked.
But it felt a little clunky.
Right. It was like we were using a sledgehammer to crack a walnut.
Exactly. So how can we optimize this? What's a smarter way to do this conversion?
Well, one approach that you'll see a lot is what I call the smart left-to-right scan.
A smart left-to-right scan.
Yeah, this method, it takes advantage of the fact that certain combinations of Roman numerals always represent specific values.
You mean like how IV is always 4 and IX is always 9?
Exactly. So instead of looking at each Roman numeral symbol individually.
Okay.
We can look for these common subtractive combinations directly.
I see. So instead of doing multiple comparisons and subtractions to figure out that IV means 4, we can just, like, hard code that knowledge.
Precisely. We can create a mapping that includes not just the individual symbols, but also these common pairs.
So our mapping would have I for 1, V for 5,
Yeah.
and then IV for 4.
Exactly. And then as we scan the Roman numeral string from left to right, we check if the current symbol and the next symbol form one of these special pairs.
Okay.
If they do, we grab the pre-calculated value from our mapping and add it to our running total.
And if they don't form a pair?
Then we just treat the current symbol as a standalone numeral.
Gotcha.
And add its value to the total.
That makes a lot of sense. So this smart left-to-right scan, it seems like a much better way to go than that brute force method.
Oh, yeah, definitely.
Yeah.
But I'm still curious about that right-to-left approach you mentioned.
The backward one.
Yeah, where we scan the Roman numeral string backward.
That one still kind of boggles my mind.
I know it seems counterintuitive, but it's actually really elegant. Remember how we talked about the last Roman numeral character always being added to the total?
Yeah, because it's either a standalone numeral or the larger part of a subtractive pair. Like in IX, the X is always added.
Right, and in 12, the I is always added.
Exactly.
So we can use that fact to simplify our logic.
Okay.
We start at the very end, the rightmost character of the Roman numeral string, and initialize our total with its value.
So we're starting with a guaranteed addition.
Exactly. Now we move one character to the left and compare its value to the character we just added to the total.
And that tells us whether to add or subtract.
Right. If the current character's value is less than the value to its right, we subtract.
Okay.
Otherwise, we add. And we just keep doing this, working our way backward through the string until we get to the beginning.
So we're basically building the integer value in reverse.
Yeah. But in a way that gets rid of a lot of those checks and comparisons we had to do with the other methods.
No more worrying about going out of bounds.
Exactly. So this right-to-left approach is both clean and efficient. Since we're only iterating through the string once, it's just as efficient as the smart left-to-right scan.
Wow. So now we have two optimized approaches. Smart left-to-right scan with its pre-calculated pairs.
Yeah.
And this elegant right-to-left scan that goes backward. They both seem pretty cool. What are the trade-offs? Which one is better?
That's a great question. Honestly, it depends. Actual preference coding style, the specific constraints of the problem. Sometimes that smart left-to-right scan, it just feels more intuitive.
Yeah, it follows the way we normally read.
Right. But sometimes that right-to-left scan might give you cleaner and more concise code.
Because of that last character property.
Exactly. So it's like having different tools in your toolbox.
And we choose the one that feels best for the job.
Exactly. Now, before we jump into actually writing the code for these approaches, what are some common gotchas we should be aware of when working with Roman numerals?
Yeah, like what are some mistakes that people tend to make?
Well, one common one is forgetting to handle all the possible subtractive combinations. You know, it's not just IV and IX.
Right.
We also have to account for XL, XC, CD, and CM.
It's easy to miss one of those.
Yeah, and then you end up with a wrong result.
Okay, good point.
Yeah.
What else?
Another potential pitfall is not handling invalid Roman numeral strings gracefully.
Invalid strings.
Yeah. You know, in the real world, our code might encounter input that doesn't actually follow the rules of Roman numerals.
Like someone tries to give us a string with letters that aren't even Roman numerals?
Yeah, or they use too many subtractive pairs in a row. It happens.
So we need to validate the input.
Exactly, and handle those invalid cases properly.
We could throw an exception or return an error code or give the user a message explaining why their input is bad.
Right. It's all about robustness.
We don't want our code to crash just because someone got a little too creative with their Roman numerals.
Exactly. So are you ready to see how these optimized approaches actually translate into code?
You bet.
Yeah.
Let's dive in. Welcome back to AI.Code.Cast. We spent the last two parts of our deep dive really digging into this whole Roman numeral conversion thing.
Yeah, we started with that kind of clunky brute force approach.
Right, and then we moved on to some much more elegant solutions.
Those optimized algorithms, the smart left-to-right scan and the right-to-left scan.
Both super clever in their own way, taking advantage of how Roman numerals are structured.
But how do those approaches actually look in code?
Yeah, and how do they compare when it comes to performance?
Let's find out. Now, I know we're not going to write out the code line by line here.
Right.
But can you walk us through the general structure of each algorithm? Like, how would we actually implement them?
Absolutely.
Yeah.
So let's start with that smart left-to-right scan. The one where we pre-calculate those Roman numeral combinations.
Yeah, it's like building a decoder ring.
Giving our code the secret to cracking the Roman numeral code.
Exactly. So in our code, the first thing we do is create a dictionary or a hash map to store that mapping.
Okay.
You'd have entries for individual symbols like I for 1 and V for 5, and then also those special subtractive pairs like IV4 and XC for 90.
So we do all the hard work up front so the algorithm can just fly through the conversion.
Precisely. Once we have that mapping ready to go, we can start going through the Roman numeral string. And at each step, we take a look ahead. Peek at the next symbol.
To see if they form one of our pairs.
Exactly. And if they do, bam, we just grab that value from our mapping and add it to our total.
No need for any math.
Right. And if they don't form a pair, no problem. We treat that current symbol as a standalone numeral and just add its value.
Makes sense. That's a really streamlined approach.
It is. Now let's talk about that right-to-left scan. This one's a little trickier to wrap your head around.
The backward one always gets me.
But it's elegant. Remember that guaranteed addition at the end of the Roman numeral string?
Oh yeah, because the last character is always added, whether it's on its own or part of a pair.
Right. So we use that fact to our advantage. We start by setting our total to the value of that rightmost character.
So we're starting with a sure thing.
Exactly. Then we start moving to the left one character at a time.
Okay.
And each time we compare the current character's value to the one we just added to the total.
And that tells us whether to add or subtract.
You got it. Less than, subtract, greater than, or equal to, add. We just keep doing that, working our way backwards until we hit the beginning of the string.
So we're building the integer in reverse, but in a really clever way.
And the best part is we don't have to do all those boundary checks.
Like with the left to right methods.
Exactly. It's all very clean. Now, technically, both of these approaches have a time complexity of O(n), where n is the length of the Roman numeral string.
So they're both linear in terms of efficiency.
Which is good.
But in real life, is there any difference in how fast they run?
Honestly, in most cases, the performance difference between the two is tiny. They both get the job done with similar efficiency.
So it's more about which style you prefer.
Exactly. Some people like going left to right, others like the elegance of right to left, and sometimes the specific problem you're working on might make one a slightly better fit than the other.
It's about using the right tool for the job. So any final thoughts on how to handle Roman numeral conversion if it comes up in a coding interview?
I'd say the most important thing is to show that you understand the problem and you have a plan for solving it. Don't be afraid to start with a brute force solution just to get your thoughts organized.
Like sketching out a rough draft.
Right. Then once you have something working, start thinking about how to make it better. Think about the pros and cons of different approaches and be ready to explain why you chose the one you did.
Show off those problem-solving skills.
Absolutely. And even though we've been talking about Roman numerals specifically, the big ideas here apply to tons of coding challenges.
Like pre-calculating values and making smart comparisons.
Exactly. Those tricks can help you write cleaner and more efficient code in all kinds of situations.
So next time you're faced with a tricky coding problem, channel your inner Roman. And remember, there's always more than one way to conquer it.
And sometimes the most elegant solution comes from really understanding the problem's quirks.
Well said. Thanks for joining us on this deep dive into Roman numeral conversion.
Happy coding, everyone.
See you next time.